Good morning everyone. This is our report in chapter 23 entitled Capital Asset Pricing Model and Modern Portfolio Theory. These are the reporters. First reporter is me, the Divine Grace B. Felicilda. And the next reporter would be Auditor Evelyn. And the third one is Lagari April. And the last one is Matukan Jenny. These are the learning objectives in this chapter. First is understand the concept of the capital asset pricing model. Second is to distinguish between diversifiable or systematic risk and undiversifiable or market risk. The next one is to understand how to measure the variability of a probability distribution using standard deviation. The next one is to calculate and interpret beta coefficient for a stock. The next one is to calculate and interpret the portfolio beta coefficient, explain the relationship between risk and rate of return, understand the significance of the security market line, and the last one is to know the concerns and constraints in using beta as a measure of investment risk. First, what is the capital asset pricing model? Capital asset pricing model is one of the major developments in modern financial theory, widely used in investment analysis. The capital asset pricing model is widely used throughout the finance for pricing risky securities and generating expected returns for assets, given the risk of those assets and cost of capital. Capital asset pricing model is a model based on the proposition that any stock's required rate of return is equal to the risk-free rate of return plus a risk premium that reflects only the risk remaining after diversification. This model also provides a general framework for analyzing risk-return relationships for all types of assets. In evaluating these relationships, the capital asset pricing model does not use total risk, which is measured by standard deviation, as a risk measure, but only one part of total risk called systematic risk. The capital asset pricing model also describes the relationship between the systematic risk and expected return for assets, particularly in stocks. And the capital asset pricing model also is the one who helps the investors understand the returns they can expect given the level of risk that they assume. Total risk also may be separated into two major components. First is the diversifiable risk, also called unsystematic risk or company risk. It is a risk that part of securities risk caused by factors unique to a particular firm. Unsystematic risk can be diversified away because it represents essentially random events. Negative events affecting one firm can be offset by positive events affecting another firm. Unsystematic risk, also known as a specific risk. These are the risks that are unique to each asset, in which individual stocks face risk from adverse developments at companies that may not impact any other firms. For instance, and these risks are not correlated across different assets, unlike systematic risk. And the next one is the undiversifiable risk, also called systematic risk or market risk. Is a part of securities risk caused by factors affecting the market as a whole. Systematic risk cannot be eliminated by diversification because it affects all firms simultaneously. Systematic risk is therefore the only relevant risk and is affected by such factors such as wars, inflation, interest rates, business cycles, fiscal and monetary policies, and therefore cannot be eliminated by diversification. So, systematic risk, also called market risk, this is the general risk from developments impacting the entire economy and all investment assets. It's influenced by factors such as I mentioned earlier, interest rates, inflation, recessions, and geopolitical events like war. So, systematic risk applies to the market as a whole, which means that all assets are impacted in similar ways. So, in this diagram, it shows the effect of diversification on systematic and systematic risk, or the effects of portfolio of randomly selected stocks. So, in this diagram, it can be observed that as the number of stocks increases, the diversifying effect of each additional stock on unsystematic risk diminishes. So, the diversification can greatly reduce in unsystematic risk from a portfolio. It is unlikely that events such as the ones listed would happen in every firm at the same time. Therefore, by diversifying, one can reduce this risk. There is no reward for taking on unneeded and systematic risk. And also, the diversification in systematic risk is that the diversification itself cannot eliminate the risk of facing these events. Therefore, it is considered undiversifiable risk, in which this type of risk accounts for most of the risk in a well-diversified portfolio. However, the expected returns on their investments can reward investors for enduring systematic risk, in which also investors are induced to take risk for potentially higher returns. However, not all risks offer such potential rewards. The wise investors identifies this risk and eliminates them from his or her portfolio through diversification. So, if stocks included in the portfolio are carefully selected rather than adding them randomly, the graph would change. In particular, if we choose stocks with correlations with one another and with low standalone risk, the portfolio's risk would decline faster than if random stocks were added. The reverse would hold if we added stocks with high correlations and high standard deviation of expected returns. Since most investors are rational in the sense that they dislike risk, other things held constant, why would an investor hold one or only a few stocks? Why not hold a market portfolio consisting of all stocks? There are several answers to the second question. So, first is to high administrative cost and commission would more than offset the income for individual investors. Second, index fund can be used by investors for diversification, and many individuals can and do get broad diversification through these funds. The third one is some people believe that they can pick stocks that will beat the market, so they buy them rather than the broad market. And the last one is that some people can, or through superior analysis, beat the market, so they find and buy undervalued stocks and sell overvalued ones. In the process, most stocks become properly valued with their expected returns consistent with the risk. And the next reporter would be Evelyn Auditor.
Good morning, business. I'm Evelyn Auditor, the second reporter of Chapter 23. My report is all about capital asset pricing model. If we know the rest as measured by beta of a particular share, we can use the capital asset pricing model to determine that securities required rate of return. The capital asset pricing model, known as CAPM or CAMP, is a model developed to help determine a share's required rate of return for a given level of risk. If an individual chooses to invest her money, then she must postpone consumption, right? What rate of return would our investor demand just to postpone her consumption? We implicitly assume that the investor takes on no risk whatsoever but merely postpones consumption. She will want compensation for the wait plus an additional return for any inflationary pressures, an inflation premium. So, if our investor demands a 3% return to postpone consumption and another 2% to cover the expected rate of inflation, she would require a 5% rate of return. That is, the risk-free rate of return is 5%. For now, let us put her funds into a restless security that pays a 5% rate of return. We tend to think of treasury securities as a good proxy for a restless asset because there is no default risk. The required rate of return is equals to rest free rate is equals to 5%. So let's proceed to the next slide. Now, what would it take to get our investor to move from a risk-free asset to a risky asset? That would depend on the quantity of risk or beta the asset had and what price our investor charges for risk. Additional The illustration look like this. Additional compensation required for investment in a risky asset is equals to price per unit of risk multiplied by beta. We measure the price of risk as a difference between the rate of return on the market as measured by the rate of return on the S&P 500 index and the risk-free rate of return. So the illustration look like this. Price per unit of risk is equals to the return on the market minus risk-free rate. So in this, we can measure the quantity of risk with a stock's beta coefficient. Recall that by definition, a restless asset has a beta of 0.0 and the market has a beta coefficient equal to 1.0. The market therefore has 1 unit of rest. If we have multiplied the price of rest times the beta, we can determine what our investor is charging per unit of rest. Additional compensation required for investment in a risky asset is equals to price per units of rest multiplied by beta. The required rate of return on that security is computed as follows. Required rate of return is equals to risk-free rate plus return on the market minus risk-free rate multiplied by beta. So let's proceed to the next slide. So what is beta? Beta is a measure of the sensitivity of securities return relative to the returns of a broad-based market portfolio securities. Beta is defined mathematically as the ratio of covariance of returns of security and market portfolio to the variance of returns of the market portfolio. Covariance is an absolute statistical measure of the extent of two variables just as securities move together. And beta measures the co-movement between a stock and the market portfolio. So the tendency of a stock to move with the market is reflected in its beta coefficient, which is a key element of the CAMP. The succeeding analysis of risk in a portfolio setting is a part of the capital asset pricing model, which is CAMP. Next, an average risk stock is defined as one that tends to move up and down in step with the general market as measured by some index such as the Dow Jones Industrials and S&P 500 or the New York Stock Exchange Index. So the beta coefficient concept, what is it? Beta is a measure of sensitivity. Sorry. So let's proceed to the next chapter. To the next slide. This figure shows figure 23-2 and figure 23-3. Figure 23-2 shows relative volatility of stocks of A, B, and C. Figure 23-3 shows illustrative list of beta coefficient. And now I will give the floor to Miss April Lagari to discuss the calculating of beta coefficient and for further discussion. Thank you.
Good morning, business. My name is April Lagari, the third reporter. Calculating beta coefficient. Historical realized returns over the last 5 years. This is the data of the calculating beta coefficient. The average of 14.9%. Market stock 14.9%. The standard deviation 15.1 and the stock 26.5. Procedure. Plot the data points on scatter diagram and draw a line of regression. If the data points had fallen on a straight line, it would be easy to draw an accurate line. If not, fit the line either by oculars, inspection, approximation, or with a calculator. The simple regression line equation means y is equal to a plus bx plus e, where y stands the dependent variable, a is the constant, b slope, return on the stock given during a given time period, x is the kilometer, e is error term, deviation for the year. This varies randomly from year to year, depending on company-specific factors. Once the data have been plotted and the regression line has been drawn on a graph paper, we can estimate its intercept and slope, the a and b values in y plus a plus bx. The intercept a is simply the point where the line cuts the vertical axis. The slope coefficient b can be estimated by the rise over run method. This involves calculating the amount by which k increases for a given increase in kilometer. For example, we observe that in figure 23-4 that k increases from negative 8.90 plus 7.1%. The rise When km increases from 0 to 10%, the run, thus B, the beta coefficient, can be measured as follows. B is equal to beta equals rise is equal to y is equal to 7.1 minus negative 8.9 equals 16.0 equals 1.1. The regression line equation enables us to predict a rate of return for stock J given a value of key M. For example, if key M is equal to 15%, we would predict key J is equal to negative 8.9% plus 1.6 or 15% is equal to 15.1%. However, the actual return would probably differ from the predicted return. This deviation is the error term for the year, and it varies randomly from year to year depending on company-specific factors. Note, though, that the higher the correlation coefficient, the closer to the points lie to the regression line, and the smaller the errors. In actual practice, monthly rather than annual returns are generally used for key J and key M, and 5 years of data are often employed. Thus, there would be 5 times 12 is equal to 60 data points on the scatter diagram. Also, in practice, one would use the least square methods. In actual practice, monthly rather than annual returns are generally used for key J and key M, and 5 years of data are often employed. Thus, there would be 5 times 12 60 data points on the scatter diagram. Also, in practice, one would use the least squares methods for finding the regression coefficients A and B. This procedure minimizes the squared values of the error terms. It is discussed in statistics courses. This is the historic realized returns on the stock. From year 1 to 5. They intercept in negative 8.9%. Portfolio beta coefficient. A portfolio consisting a low beta securities will itself have a low beta because the beta of any set of securities is a weighted average of the individual securities betas. The beta of the portfolio reflects how volatile the portfolio is in relation to the market. For example, if an investor holds a 1 million pesos portfolio consisting of 333,333 invested in each of 3 stocks, and each of the stocks has a beta of 0.8, then the portfolio's beta will be BP equals 1/3 times 0.8 plus 1/3 times 0.8 plus 1/3 times 0.8 is equal to 0.8. Such a portfolio will be less risky than the market. It should experience relatively narrow price swings and have relatively small rate of return fluctuations. Using the scatter graph, the slope of the regression line would be 0.8, which is less than that for a portfolio of average stocks. Suppose that one of the existing stocks is sold and replaced by a stock with B1 equals 2. This action will increase the riskiness of the portfolio from B1 equals 0.8 to B2 equals 1.2. Adding a new low beta stock would reduce the riskiness of the portfolio. Good morning, business. I am the next reporter. I am Jenny Mathukan. Relationships between risk and rate of return. Financial managers and all managers, for that matter, must have a firm grasp upon the trade-off between risk and return. A firm's product mix, marketing campaign combination, and research and development programs all entail risk and potential rewards. Being able to understand and characterize these decisions within a risk and return framework can help managers make better decisions. In addition, managers must understand what return their stockholders require at various times at firm operations. After all, a firm must receive enough revenue from its various risky activities to pay its business cost, debt cost, and reward the owners. Managers must thus include the return to shareholders when they analyze new business opportunities. The CAPM expresses risk-return relationships using beta as the relevant risk measure. CAPM states that the required rate of return on a risky asset consists on the risk-free rate plus a premium for systematic risk. The formula for the capital asset pricing model is where RI required or expected return on security, RF expected risk-free rate of return, RM expected return on the market portfolio, BI coefficient of security. The risk-free rate of return is the return required on a security having no systematic risk and is generally measured by the yield on short-term treasury securities such as treasury bills. That the risk-free rate consists of two components: a real rate that excludes any inflationary expectations, and an inflation premium that equals the expected inflationary rate. The risk-free rate exchanges in the same direction and by the same amount as the inflation premium changes. Since the risk-free rate is part of a security's required rate of return, a change in inflationary expectations will also increase the acquired return on all securities. The risk premium is the return required in excess of the risk-free rate and is due to systematic risk. Part of the risk premium is the market risk premium, which is the additional return expected for holding a market portfolio of average riskiness. The risk premium for a specific security will differ from the market risk premium if the individual security beta does not equal to 1.0. So, need you ta mo take og risk. Mo ni siyang kung security market line. The CAPM is expressed graphically by the security market line. The security market line represents the linear relationship between a security's required rate of return and its risk as measured by beta. The slope of the SML is the market risk premium and is constant. CAPM can also be used to calculate a market-based hurdle rate for evaluation purposes. A hurdle rate is the minimum rate of return required for a project to be accepted. If an asset's expected rate of return equals or exceeds the required return, it falls on or above the SML. As computed by CAPM, the asset is accepted, otherwise it is rejected. In equilibrium, the required return of an asset or security equals its expected return. There are concerns about beta. The CAPM is based on restrictive assumptions about investor behavior and the securities market. Assumptions about investor behavior include investors are risk averse and expect to be rewarded for taking risks. Investors act rationally and prefer a security with the highest return for a given level of risk or the lowest risk for a given level of return. Investors make their decisions based on a single time horizon, that is, investors view the asset's risk and return characteristics for the same time period, such as a year end. Investors share the same expectations about the risk and return characteristics of securities. Number 2, assumptions about the securities market include all investors can borrow or lend in unlimited amounts at the risk-free rate. Financial markets are frictionless in that there are no taxes or transactions costs. All assets are perfectly divisible and perfectly liquid, and information is available to all investors. And that's all. Thank you for watching.